Good morning, friends. It gives me immense pleasure to be here for my course Aircraft Systems. Today's topic is about optical fiber in aircraft control. As you know, my name is Dr. Dwivedi, Professor from Institute of Aeronautical Engineering, Hyderabad, India. I am in the last phase of my course, and before that I have completed Module 1, Module 2, Module 3, Module 4, and this is my last class for the course. Next, I will be discussing about some new cases, case studies, question banks, definition and terminology, and all I will be discussing from my next classes onwards. But this is, as per the syllabus, this is my last class for aircraft system. In this class, I am going to discuss about optical fiber in aircraft control. What is optical fiber and how these things are used, I am going to discuss in this course. These are my topics for the day. I am going to take the optical fiber, the introduction. Then I will go to connectors used in optical fibers, fiber cable constructions, advantages, types of optical fiber and its application. These are covering the course outcomes CO6. COs all are in the CO6, and as it is the last unit, so all are matching with the mapped with COs and POs as per given here. Optical fiber optics in aircraft introduction. Fiber optics can handle high bandwidth application, way less than copper wire, are more immune to electromagnetic interference, and are more reliable. So, why we use? So, first thing, it can handle a very high bandwidth, then the weight of these cables are very much less than the copper wire. They are very much immune to electromagnetic interference. So, if especially for defense forces and all, this electromagnetic interference will generate the noise, and your communication, your navigation, all systems will be disturbed. So, accuracy of missile, accuracy of aircraft flight, the navigation, communication, other radar, ADF, all these items will be getting disturbed, and your required results will get disturbed, and the accuracy of the system will destroy. Fiber optics connectors and components manufacturers are innovating to enhance the cockpit management and revolutionize aircraft cabin system. So these are some basic introduction. Why we use the fiber optics in aircraft? Because main thing in aircraft, we should try to reduce the weight. Also, it should be able to handle very high bandwidth data for the communication, for the transmission, and also it should not be leaked. Data should not be recorded. It should not be leaked. So electromagnetic interference has to be very, very minimum. And that is the purpose it is serving the fiber optics. So for the fiber optics, we need some special connectors. It is not normal. So I am going to discuss in this further. So advantage of fiber optics, I am part of introduction only, and further I will be discussing a good comparison I have shown here. I have given here the references 1 and 2 here. These I have taken from these books. So advantage of fiber optics. Fiber optics support bandwidth over 60 terabytes per second. Copper can only handle up to 10. So it is 6 times bandwidth capacity of the fiber optics is more than the copper wires. Then light in weight, the fiber cable weight is 4 pounds, but copper weight 39, nearly 10 times for 1000 feet of the cable. So it is, if you take 1000 feet of the cable, the weight of the fiber cable will be 10 times less, or if you see the copper, it is 10 times more than the fiber cables. Better signal integrity, repeater needed every 30 miles for FC, but for copper it is 30 miles. So we need for a better signal integrity, we have to use a repeater for every 30 miles, but for the copper we need every 3 miles. So means the repeater is also 10 times more in copper. So in a 30 miles we need only one repeater, but if you use the copper cable, it required every 3 miles we need a repeater to give the signal integrity. Fiber cables are immune from EMI, and that is electromagnetic interference. Just now I have explained, and they are very high security as the signal leakage are very less. The interference or the emission of the signal from the fiber cables are very less comparing to the copper cable or the aluminum or other material. Copper is next to the fiber cable. Normally we use the fiber in this copper cable, but for the modern communication and this laying off the line of this communication and transmission, normally we use nowadays a fiber cable. So many avionics application require high speed operations. Military fighter is equipped with high performance radar to detect both targets and incoming missiles. A 4K or 8K high resolution radar image display in the cockpit requires high speed processing. Video cameras on board the fighter are digital compression to preserve system bandwidth, but at the cost of latency and delayed image display. These trade-offs will be unnecessary in avionics using fiber optics. So if we use the normal copper wire, so many avionics application requires high speed operation. So in avionics or in the radar system or the helmet mounted display or HMD, these all things required very high resolutions, and especially the military fighters is equipped with high performance radar to detect both targets and incoming missiles. So for this we need a 4000 to 8000 high resolution radar images displayed in the cockpit, requires high speed processing. So we need very high speed processing systems in the aircraft. Video cameras on board the fighters use digital compression to preserve system bandwidth, but at the cost of latency and delay in image display. So if we do like this, we compress this thing, it will delay the image display, and also the latency of this thing will be reduced. So these trades-off will be unnecessary in avionics. So like this agreement, it is not good for avionics. So these fiber optics are very useful in this type of scenario. Now, fiber optics based system will be able to deliver real-time imaging without digital or video compression. So if we use the fiber optics, we need not to compress. In the original form it will be available, and this delay and the latency of this thing will be avoided. It will not be there. So this is the big advantage, and accuracy and the time saving of the analysis can be done. higher speed interface such as 4000, 8000 video, LIDAR and other target acquisition and avoidance system will drive the demand for fiber optics. The next generation military fighter platform will need to transport 100 terabytes of data with extremely low latency and process that information in sub-second interval. So, as we see that G5 or next gen or this 5G aircraft like Rafale, this like our F-22, F-35 and all, Su-57, they are called the 5G aircraft. In this type of aircraft, the 100 terabits of data with extremely low latency and processing is required. So, we need these all things. The passenger aircraft situational awareness will be enhanced by using of the fiber cable. So, in not only the military aircraft, but our passenger aircraft also nowadays, they use the situational awareness, because where is the location of your aircraft? There is a anti-collision, that is called the TCOS systems. So, that also need a huge amount of data so that it can find out its situation and nearby aircraft which are flying. So, the autopilot or this your automatic control of the aircraft can be achieved. Here I have put some a Curtiss-Wright's COTS-based video format converter XMC FC1 supports XMC Vita 42 mezzanine card form factor, can convert 15 different analog and digital video format. So, this equipment which is here, this can format a very high accuracy and with very high speed. It is called XMC FC1 rugged video gateway format converter module, which support 15 different analog and digital video format and resolution, and ARNIC 818 avionics. This is the figure. Okay, just digital video bus to simplify avionics video conversion. This is the reference 2 and 3. Now we have to use another type of the connectors. It is called the fiber cable connectors. Here it is shown the connector. It is called Radial's QM Titan series is ARINC 846 complaint. Its contact support of the self multi-pin connectors such as military DTD 38999, ARNIC 600NX, EN4644, EPX, EN4165 connector. So these are the coding of the connectors. These types of connectors, this can be used in the optical fibers. It is depiction of the connector which is shown here. Interfaces for the fiber cable, it is few are here shown how these things are working. They are the reflex photonics, optical fiber transceiver, support A, BGA electrical interface. This is the A, this is the B, and this is the C. So A is the BGA electrical interface, then MEG array electrical interface, this is the B, and C is the LGA electrical interface. So these are the interfaces. They will support the fiber optics by use of this type of connectors. The connectors of fiber optics are not same as the connectors of the copper wire or the another wire. It is different types of connectors are used. Now I will talk about the connectors and the cable harnesses for the fiber cables. So here I have shown here extended temperature optical fly micro flyover system. It is shown here and how these connectors are attached. So instead of having one cable harness, aircraft can use a fiber optics cable harnesses in a modular format, much like a hardware system with multiple plug-in modules. If one module fails, a new module can be plugged in to replace the defective one. So here this 1 and 2. If one is failed, this is the 1 and this is the 2. If the one is failed, another can be replaced. So this is the connectors and the cable harnesses. This type of connectors and cable harnesses are used nowadays for unmanned aerial vehicle UAVs, are one area that could greatly benefit from future improvement to the ultimate goal of the avionics. So as and when the technology is developing, our fiber optics technology is growing, this type of connectors will be used in unmanned aerial vehicle, autonomous vehicle, or any modern fighter aircrafts, even passenger aircraft, even your vehicle also. These things are going to be used in the for the automated car also, like Tesla and all. Like this type of technology is used there also. Now I will discuss about optical fiber. What is the optical fiber and how it is working? Okay, so here optical fiber or the fiber optics, both are the same, refers to the medium and the technology associated with the transmission of information as light pulses along a glass or a plastic strand or fiber. So in this, what happened? The fiber optics refers to the medium and the technology associated with the transmission of information. So in this, information will transmit as a light pulse. It is not as a current pulse. It is a light pulse along a glass or a plastic strand or fibers. So that is the difference. Optical fiber carries much more information than conventional copper wire and is in general not subjected to electromagnetic interference and the need to transmit signals. So this is also, so here it is transmitting as a light pulse, and this is also a much lighter and it can carry much more information than the conventional copper wire and is in general not subjected to EMI, electromagnetic interference, and the need to transmit signal. So accuracy and the noise or disturbance is quietly minimum. Now the fiber optic system, communication system that uses light as the carriers of the information from a source to a destination through a guided fiber cable, glass or plastic, are called the fiber optic system. Oh, so what is the fiber optic? In this we use glass or some type of plastic from where data is transmitted. The information carrying capacity of a communication system is directly proportional to its bandwidth. So as much you have the bandwidth, that much fast communication it can be done, and it is directly proportional to the capacity of the communication. The wider bandwidth, the greater is the information carrying capacity. As you have the wider bandwidth, that much information it can carry more and more. Because of high information carrying capacity and low attenuation, nowadays fibers are finding the wide applications in telecommunication, local area network, sensors, computer network, and so on. So if you see nowadays, your all the communication, even television, this channels, your all networks are operated by the fibers, and telecommunication, LAN, sensors, computer networks, all are operated by the help of the fiber optics. Now I am going to discuss about fiber optics advantage over metallic cable. This you can see here. We have here, it is a copper cable, and this is the fiber optics. So this you can see how big, how many wires 1, 2, 3, 4, and everyone you have some 20. So some nearly 100 wires are there. But here, if you see a very, very glass fiber, very small, thin, one fiber will go inside. Okay, so here glass fiber is entering here. Then we have the hermetic seal. Then we have the coating on top of that. Then we have the strengthening members, and then we have the jacket. So these are the layers here. So only one wire will enter from here, and so you can see the weight, how much reduction of the weight you can, and the size, everything is tremendously reduced by just I have compared here this two diagram. So now extremely wide, large bandwidth. So the first and the foremost advantage of any fiber optic is its bandwidth is very high comparing to the normal copper wire. The bandwidth available with a single glass fiber, as one glass fiber can carry up to 100 gigahertz of the bandwidth. With such a large bandwidth, it is possible to transmit thousands of video conversions or dozens of video signals over the same fiber simultaneously. If it is like this, without any problem, immediately it can be transmitted. Irrespective of whether the information is voice, data, or the video, or a combination of these, it can be transmitted easily over the optical fiber. So this is very useful for any type of data, let it be video or voice call or the combination of these, or any different communication, and very easily it can be transmitted. Whereas only a very less number, this 40 to 50 of independent signals alone can be sent through the metallic cable. So in this only 40 to 50 signals, independent signal, but here you can send thousands of signals at a time. So that is the difference between these two. Now, so first one was the large bandwidth. So it means it can carry 100 gigahertz, but copper wire, one wire cannot carry even 1 by hundreds also. So that is the first thing. Second thing, immunity to electrostatic interference. So the interference is very less. As it is transmitting, the leakage of the signal is also very less. So that is the benefit of this thing. As optical fibers are being made of either glass or plastic, external electrical noise and lightning do not affect the energy in a fiber cable. So it is current resistance, fibers are there, plastic is there. So the interference of electrical equipments will not be there. The result is a noise-free transmission. So a noise-free means the disturbances of the communication will be very less. However, this is not true for metallic cable. If you use the copper or any other metallic wire made of metals, as they are good conductor of electricity. So if like this you are using, then it will disturb your system and the noise will generate, and this will affect its performance of the system. And if you are launching missile or anything, your electromagnetic problem will be generated and missile will be misguided. So that we have to think of. Third one is the elimination of the crosstalk. So by the meaning, sometimes what happened, we are calling by the mobile to someone, but someone else is also connected. You are not aware. So the third person is listening your words. So in this, if you are using this fiber cables, the elimination of crosstalk is tremendously reduced or avoided. Fiber systems are immune to crosstalk between cables caused by the magnetic induction, whereas in a metallic cable, crosstalk results from the electromagnetic coupling between two adjacent wires. So if two wires of copper are going, so one wire will transmit to the another, the leakage will be there. The same signal may go to other place also. So if you are using the copper cable, there is a chances of leaking of your information, which is not good for any safety, especially for defense forces and other. If we do like this, the communication will leak and there may be some problem. Next is lighter weight and the smaller size. So optic fibers are very small in size. The size reduction make fiber the ideal transmission medium for ships, aircrafts, and the high-rise buildings where bulky copper cables occupy too much of space. So especially for the aircraft, because I am very much concerned about the aircraft. So this in aircraft is very useful, because in aircraft weight is very important parameter. How much we can reduce the weight, that much efficiency of the aircraft, the performance and aircraft stability will be improved. Also, the thrust produced by the engine will also be reduced if the weight of the aircraft is reduced. So that is why in aircraft we are very much concerned about the reduction of the weight. The design should be in such a way that the aircraft weight, it should be minimum. And here if we use the fiber optics, the weight of the aircraft is tremendously reduced. And nowadays we use the fiber optics in most of the modern aircraft. Reduction of size is reduction of the weight also. So if the size is reduced, the weight of this aircraft is also reduced. The cost. Next factor is the cost. The price of this thing is also very good, because it is made of silica or glass or the plastics. So the material used in fiber is silica or silicon dioxide, which is one of the most abundant material on earth, resulting in lower cost. Optical fiber costs are continuing to decline, and slowly this cost is going to decline. This is the silica, it is available in our sand and all, and this is the silicon dioxide, this is shown here, and this chemical construction is also shown. Especially in India, we have a sufficient amount of silica everywhere on the river banks and these things. There is no scarcity of the silica and the silicon dioxide. Okay, here it is shown. So it is very much sufficient available, and also the slowly the cost of manufacturing cost is also coming down. So this will be abundantly available for all the uses. Next point is the security, especially for the defense forces and all, the security, and for personal also the security is very important, and it should be secure. Your any communication, it should be properly safe and secure. So fiber cables are more secure than the metallic cable due to its immunity to electromagnetic coupling and the radiation. Optical fibers can be used in most secure environment. Although it can be intercepted, it is very difficult to do so, because at the receiving user's end an alarm would be sounded. Okay, so here also some alarm will be sounded. So if you see, only one wire will go in the fiber cable, but if you take the copper wire, there are a bundle of wire will be going like this. So weight is in copper wire, weight is increased, but in the fiber cable or optical fiber, only one wire of the very small thin wire will move, and it is covered by different layers like this I have shown you. So the leakage of this thing will be reduced. However, if anyone is trying to trap or take out the signal, it will give the signal that there is something is going to happen. You will get some alarm. So that is also the advantage of the optical fiber. Now the greater safety. So another advantage is the greater safety of this. In many wired system, the potential hazard of short circuit requires precautionary design. So in copper wire, always there will be a short circuit, there will be a fire and all. So this can be avoided by, whereas the dielectric nature of the optical fiber eliminates the spark hazard. So this spark hazard of this system is also avoided. Next is very important is the corrosion. Corrosion, if taking place, the life of the system will reduce, the strength of the communication will be reduced, the accuracy of the communication will be reduced, and it will fail very fast. To avoid that thing, fiber cables are more resistive to environmental extreme, as the plastic and the glasses are not very much affecting to the environmental condition. They operate over large temperature variation than their metallic counterparts and are less affected by corrosive liquid and gases. Longer life and easy to maintenance. So a longer life span of 20 to 30 years is predicted for the fiber optics, whereas for the metallic optics or the metallic wire, it is 12 to 15 years. So nearly 50% life is there for metallic transmission. Okay, so that is also advantages. Now I will explain about the construction of the fiber optics, and this you can see a very small core is there, very thin. This is here, a very thin core is here. Then on top of this fiber we have a cladding, a very thick plastic material which is cladded this. After that we have a coating. After that we have the strengthening fibers. This is not the communicating, they are used to strengthen this, that this wire should not be damaged. Then we have the cable jacket, a plastic cover is on top of this. Most of, if you see in our road and all, they will have some reddish or some orange in color, it is used. So it is a construction, and it is demonstrated here that there should be a core. Then in this core is a wire, a glass wire, it is here. This is wrapped over by the cladding, a very hard plastic. Then over that we may make some coatings, some resistance coating. Then we have some fibers to give them strength. The shocks and all, it should be absorbed. And then we have the cable jacket here, which holds all these items very firmly. So there are many different cable design available today. So depending on the configuration, the cables may include a core, a cladding, a protective tube, a polyurethane compound, and one or more protective jackets. So this you can see here, one jacket is here, and this is the coating. The fiber cable consists of a core at the center and a cladding outside the core. So this you can see here, this is the core, and outside this it is a cladding to support that thing. Then we have a buffer jacket, provided protection for the fiber from external mechanical influences that could cause fiber breakage or excessive optical attenuation. So we have the jacket, it is called the buffer jacket, and so it is any mechanical loading or some twisting or bending, anything is there, it will be absorbed by these things. That is why this strengthening fibers are used. Surrounding the buffer jacket, there is a layer of strength member called the Kevlar, a yarn type material. This is the Kevlar material. It is, I think, it is a fibers. These fibers are used for aircraft fabrication of the wing, fabrication of the fuselage and all. These Kevlar fibers are used. So surrounding the buffer jacket, there is a layer of strength members called the Kevlar, a yarn type material, which increases the tensile strength of the cable. Again, an outer protective tube is filled with polyurethane, which prevents moisture from coming into the contact with the fiber. The type of cable construction used depend on the performance requirement of the system and both the economic and the environmental constraint. Now I will talk about the fiber optics. So here the types of fiber optics we have here. Plastic, first one is based on the material. Plastic core with plastic cladding, plastic core with glass cladding, glass core with glass cladding. Based on the mode of the transmission, single mode fiber and multiple mode fiber, and then we have index profile, step index and graded index profile. So here I will first talk about the based on the material. Different materials are used. Accordingly, we have to see that it is made as per that. So first one is plastic core with plastic cladding, means plastic to plastic. This type of fiber cable have same material, so it is easy to production, but it is less expensive and easy to install. Mostly used in short distance and have a capable of 6 Mbps. It is a low cost in this plastic and plastic. Means your cable and the cladding both are the plastic. This you can see what is the cladding here. This is the core and this is the cladding. This one and this one. Both are the plastic. So if you see here that this is your plastic, and above this we will make a cladding also. This is the cladding. This is also plastic. Okay, so plastic to plastic, it is less expensive and easy to install. Mostly used, but it is for less broadband. Speed is 6 megabytes per second. Okay. Second one is glass core with plastic cladding. So in this you can see here, glass core with plastic cladding. It is having a low signal loss. Means it is better than the first one. Less affected by the radiation. Suitable for military application. So here if you see here, this is your glass core with 0.001965 inch in diameter. Very, very thin. And on top of this, it is a plastic covering 0.009 inch in diameter. Okay. And it is cross section. And if you see from here, glass fiber optics cable, glass inch in diameter. So this is this diameter and this is your upper cladding. So this very thin, these things are used for based on the material. Third one is the glass core with glass cladding. So this is your core and it is made of the glass, very thin glass, and this is also by the glass. Okay, so it is having lower signal loss than PCS. So it is lowest among this, more susceptible to radiation area and losses signal. So it is losses are there and there is susceptible to radiation of the signals. Next is based on the mode of the transmission. So first one was based on the material. So here we have plastic to plastic, glass to plastic, and glass to glass. Next we have based on the mode of the transmission. Here we have the single mode fiber and multiple mode fiber. So what is the single mode? Here only one mode is here, single mode, and here if you see it is reflecting. So it is called multi-mode fiber. So it is having only one path for light to pass. Only one path is there. Very small diameter of core. It is 7 to 10 micrometer. It have bandwidth up to 40 gigahertz. Mostly used in a long distance and low cost circuit like TV cable. In TV cable and all we use this and its bandwidth is 40 gigahertz. If you see the multi-mode fiber, light takes more than one path to travel, more than one path. Okay, this you can see it is two paths are shown here. Core is having a diameter of 20 to 100 micrometer. Here only 7 to 10. But here the size of this thing is higher. Usually used for a medium distance and a high bandwidth. So here for the medium distance and the high bandwidth we use the multi-mode fibers. Next is the index profile of the fiber cable. So we have here step index fiber 1, then graded index fiber and then refractive index fibers. So step index fiber, what is the step index fiber? Step index have uniform reflective index of the core. Core have a bigger refractive index than the cladding. Graph of radial distance versus refractive index seems like a step index fiber. So this you can see here. Step index fiber is shown here. This is the core, this is the cladding, and this is the jacket. And how these things are, it is going like step. This step, this step. So we have 1, 2, and 3. In this way it is going. Graded index fiber. Core of graded index fiber have non-uniform. The core is not in the same type. It is not like this. It may have some uniform, non-uniform. Okay, like this. Refractive index is highest at the canter and decreases till the end of the core. So it is at the refractive index is high, at the end it is slowly it is reducing. Application of the fiber cables, we can see that where we can use the fiber cables. So first is the communication. So optical fiber is mostly used in communication from one aircraft to another aircraft, communication from aircraft to the ATC, from ATC to the aircraft, from ATC to the ground, and from different places we have to communicate, especially in aeronautics. So optical fiber is mostly used in communication. It is used in Wi-Fi router, landline phone, and the server connector. A single optical fiber can carry over 30 million full duplex voice call for 90,000 TV channels. So it is used in broad bandwidth. So this is used in here. Military, optical fibers is used to make military equipments and the weapons. It is also used to make antenna to communicate in far areas. So these things you can see that how this military people, they communicate from their radar and other places. So here we use mostly the optical fibers, and for the equipments of Army, Navy and Air Force, and for other purposes also. It is also used to make the antennas. You see here the antennas are here. This is antenna, this is the antenna, and so many antennas are fixed here also. There also we use the fiber cables. Then also we use for the sensors. In aircraft we have different types of sensors, your gyro sensors, your speed sensors, your pressure sensor, temperature sensor, RPM sensor, engine parameters, all the sensors are there. In every sensors we use the optical fibers. Most of the sensors are made from the optical fibers. Optical is also used to make detectors, that is metal detectors. So this you can see here, fiber optics sensors are here, and input fiber and output fiber. So it will light modulator here, input, and this is output, light source, it will go, and light detector. So in this way it will be working. Other applications of this fiber optics are, optical fiber is used to make lamps, decorative applications, art, toys, microscopes, and outer body of some other devices. Many medical devices are made from optical fiber. This you can see there are number of items of medical and surgery and all these things. We need a very high accuracy. This you can see the in ICU you will get such type of equipments. These are operated by the help of the optical fiber. So nowadays optical fibers are used in many places, and so this is the future technology for any new areas. These are the references which I have taken, that is Moyer I and the Seabridge, Aircraft Systems, Mechanical, Electrical and Avionics System, Professional Engineering Publishing Limited, London, and Bury St Edmund, UK. Next book is Moyer I and the Seabridge, Design and Development of Aircraft Systems and Introduction, AIA Education Series 2004. I have taken some material from this website, aviationtoday.com, and also the slides here. In this I have taken this one. Thank you very much for listening to me. Any questions you are welcome to ask. My email ID is ydwidi@gmail.com. Okay, so you can ask any questions mailing to me, or please like and subscribe this YouTube channel. Hope this will have given some knowledge on the fiber optics. Thank you very much for joining. Wish you all the best, and please do share and do subscribe. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.